There's no shortage of suspension designs out there. Neither is there a shortage of claims about what any given suspension can do for you. At GT, it's not just a claim. We design all of our suspension frames to give you the best performing bicycle possible. Because of the movement of the rear wheel that's inherent to all dual suspension designs, certain design constraints must be overcome. While some designs address only one or two limitations, GT's technology directly addresses the challenges that all suspension designs face, and GT does it without any fancy proprietary parts or shock platform valving. Our design philosophy addresses the following: pedal feedback, pedal bob, wheel path, and serviceability. Our technology helps you set up the bike easily, climb more efficiently, descend faster, and handle obstacles more effectively. What exactly is pedal feedback? When suspension compresses, the rear wheel moves away from the front chain rings. This movement pulls the chain and causes the pedals to momentarily rotate backwards. Although only a temporary condition, a rider needs to overcome the force of pedal feedback, which saps momentum, disrupts rhythm, and slows you down. Other manufacturers have tried and failed to address pedal feedback. Generally, those manufacturers use complex linkages that still have the effect of lengthening the distance from the bottom bracket and the rear dropout. In other words, the distance between the front chain rings and the cassette grows, stretching the chain. Shown here in the split screen, the colored highlighted graphic at the crank demonstrates the amount of pedal feedback occurring on each design as the suspension moves, green being minimal and red being extreme. As you can see, independent drivetrain technology experiences the least amount compared to the competitors. You're probably wondering, if pedal feedback is bad, why does independent drivetrain have any at all? This small amount of pedal feedback, which is purposely tuned into the design, is known as anti-squat and is necessary to control how much of the suspension will squat when the rider's body weight moves up and down during pedaling. We'll discuss this in more detail when we talk about pedal bob. With a full understanding of these constraints, GT's engineering team developed independent drivetrain. This design adds power to every pedal stroke by canceling chain growth, which allows all your power to go directly to the drivetrain. GT's simple, elegant isolated bottom bracket is the heart of the independent drivetrain system, effectively minimizing chain growth and reducing pedal feedback. On a horse-link system, a vertical wheel path is used to limit the distance between the axle and the bottom bracket. Although there's a small amount of improvement to increase efficiency, there's still a substantial amount of pedal feedback that the rider must overcome. The DW-Link system focuses more on eliminating pedal bob and doesn't address pedal feedback in a way to benefit the rider and remove those extra forces. VPP, the virtual pivot point technology, has also made eliminating pedal bob its main focus, and in the process has created a wheel path that increases the amount of pedal feedback. A single pivot suspension design has all of the same riding characteristics: wheel trajectory, braking performance, and suspension sensitivity as an independent drivetrain system, except for the fact that single pivot designs exhibit uncontrolled chain growth. Since they don't separate the drivetrain from the suspension, single pivot designs will experience pedal feedback. As you can see, by comparing pedal feedback in each design, the result is little to no pedal feedback on the independent drivetrain system. This allows you to maintain a smoother cadence and pedal through technical terrain with less effort.
You come out and you've got a pedaling section, you know that you can just grab gears and just charge.
You already know how GT addresses pedal feedback. Now let's discuss pedal bob. Imagine cranking up a hill out of your saddle. The weight of your body moving up and down compresses a typical suspension, resulting in dramatically decreased efficiency. This is what's known as pedal bob. In an effort to maximize efficiency, GT engineers developed the iLink system to minimize pedal bob. The iLink system uses an arrangement of pivots and a precisely located dog bone-shaped link. The iLink tunes in the perfect amount of anti-squat. Like we mentioned in the pedal feedback section, tuning in the right amount of anti-squat is an important part of a suspension design. Anti-squat is a force from your pedal stroke that acts against the suspension movement and keeps the shock from compressing. It's easy to confuse pedal feedback with anti-squat, whereas pedal feedback is an energy-robbing force your body has to overcome, and anti-squat is a force your pedal stroke puts on the suspension. Too little anti-squat, your bike will bob. Too much pedal feedback, you spend all your energy overcoming it. By eliminating pedal feedback and designing in the perfect amount of anti-squat, GT is able to design the most efficient pedaling suspension bike possible. Even when using a shock with no platform, the result is a bike with a perfect amount of anti-squat, and that minimizes energy-robbing bob. So instead of bobbing up and down with each pedal stroke, your bike moves forward.
One of my strengths in downhilling's my pedaling, and I can put quick pedals in anywhere, and the power always goes directly to the ground. Doesn't change the way the suspension works when I've got the power on.
Each and every rock, root, and rut exerts a force on the rear axle. GT's optimized wheel path, shown here in slow motion view, illustrates how GT can help you go faster through the rough stuff. Many manufacturers discount the importance of wheel path. The wheel paths on their bikes are a result of trying to improve pedaling characteristics rather than creating a wheel path that efficiently follows the terrain. An efficient wheel path means the wheel follows the same path as the bump force, because when it all works efficiently, you go faster. The FSR system uses a vertical wheel path instead of a smoother arc of rear wheel travel like the GT system. As you can see, the FSR wheel path is out of line with the actual bump force. Although this path is good for drops during which the bike lands straight down, this is not good for most of the bumps you're likely to encounter out on the trail, where the bump force acts on the wheel at the front where the tread meets the dirt. The Maestro and DW Link systems similarly use a near vertical wheel path, but the path doesn't have quite enough arc to follow the bump force. Although the path is more in line with the bump forces coming through the wheel than a true vertical path, it's far from perfect. Finally, the VPP system with its S-shaped wheel path is intended to stiffen or lock out the suspension over small bumps to improve pedaling characteristics. But the problem is that losing suspension over any size bump causes fatigue and momentum loss. Ultimately, an up and back wheel path, such as found on GTs, is what you want for the least amount of momentum loss. Here's why. On a trail, your wheels encounter rocks and other obstacles that they need to roll over. A wheel path that arcs away from the obstacle and in the same path as the bump force, like the GT's wheel path, keeps you rolling faster. But a wheel path that only moves up and down doesn't follow the bump force. It robs you of your speed on the downhill and reduces your momentum while climbing. Vertical wheel paths are jarring in rough terrain. They beat you up, rob your momentum, and slow you down.
You pedal and it accelerates, and when you hit a bump, while you're accelerating, the wheel moves out of the way and it tracks on the ground.
GT's pivot system is easy to service. GT engineers thought of everything. That's why our pivot assembly system uses commonly sized 1 1/8" headset bearings available in nearly every bike shop. The bearings are easy to find and easy to replace. In addition, our angular contact bearings aren't pressed in like some of our competitors and use preload for the easiest adjustment. Just like a headset, riders tighten suspension pivots to adjust the speed of actuation in their suspension, allowing them to adjust the pivots properly, increasing suspension performance and the life of the bearings.
As for maintenance, they're really easy to work on. The pivots are super simple, big bearings. I'm stoked to work on a simple bike like this. Makes my job easy.
GT's technology addresses pedal feedback by minimizing cadence-robbing crank movement, gives an arced wheel path to smooth suspension movement, and minimizes pedal bob for the smoothest ride out there. All of this is combined with the ease of maintenance and use of standardized bearing sizes that make GTs a snap to service.